Hi everyone, welcome back to Dev Recipes. Today we are diving into Angular Lifecycle hooks, an essential concept for building dynamic and reactive web applications. In this video, I'll explain what lifecycle hooks are, walk through an example, and show you how they work in under 5 minutes. Let's get started. So what are lifecycle hooks? Think of them as special methods Angular provides to hook into different stages of component's life. For instance, when component is created, updated, or destroyed, Angular allows us to execute custom logic using these hooks. Before diving into Angular lifecycle hooks, it is essential to first understand the change detection cycle. This is because lifecycle hooks work closely with the change detection cycle to give the developer precise control over the component's behavior during the different stages of lifecycle. So, what is change detection lifecycle? It is the process Angular uses to monitor the state of your application and ensure the DOM always reflects the current state of your components and their data binding. The cycles forms the backbone of your Angular reactivity. The change detection cycle is triggered by events such as user interactions, asynchronous operations like API calls, or the other changes in the application. Now, to make things easier to remember, we can categorize Angular lifecycle hooks into three main phases: creation, execution, and destruction. Let's break them down one by one. We have the creation phase. This is when the component is first created and initialized. Angular provides two key lifecycle hooks in this phase: ng-on-changes and ng-on-init. ng-on-changes is the first hook Angular calls. It's triggered whenever the input properties of the component or directive change. Think of it as the first opportunity to respond to the data changes. This hook is especially useful for the component that depend heavily on the input data. Next is ng-on-init. This hook runs once after the first ng-on changes and is perfect for setting up the component for the first time, like initializing data for making API calls. Use ng-on-init for one-time setup tasks, and remember, it only runs once in component lifecycle. Now let's move to the execution phase. This is where Angular handles changes, monitor content, and checks view during the component lifecycle. The hooks here include ng-do-check, ng-after content init, ng-after content checked, ng-after view init, and ng-after view checked. ng-do-check is triggered during every change detection cycle. It's like a custom change detector, where you can write your own logic to check for the changes. Use this only when Angular default change detection doesn't meet your needs, but be cautious, it can impact performance if overused. Next are ng after content init and ng after content checked. These hooks deals with projected content, which is any content you pass into a component using ng content. ng after content init runs once after the content is projected, and ng after content checked runs after every check of the content. ng after view init and ng after view checked are similar, but they handle a component's own view and any child views. These hooks are often used to access child elements or components using @viewChild. Remember, ng after view init runs once after the view is initialized, and ng after view checked runs after every check. Finally, we have destruction phase. This is when the component or directive is about to be removed from the DOM. There is just one hook here, ng on destroy. ng on destroy is your cleanup hook. It is called just before Angular destroys the component. Use it to release resources like subscriptions, event listener, or intervals. This hook is essential for preventing memory leaks, especially in apps with observables or event listeners. Alright, now that we understand what Angular lifecycle hooks are, it's time to see them in action. I have set up a simple Angular application where we will log messages inside each lifecycle hook to track when they get triggered. I have implemented all lifecycle hooks inside our lifecycle demo component. Each hook will log a message when it gets triggered. Let's take a look. With this setup, every time something happens in our component, whether it's being created, updated, or destroyed, we'll see log in the browser console. Also notice that I have added the input property. This will allow us to observe how Angular responds to input changes and trigger different lifecycle hooks. If you look at the app component, you will see that I have added lifecycle demo component inside it. What is happening here? We have input field bound to parent data using ng model. This parent data is passed as an input property to lifecycle demo component. Now, every time we type in the input field, the input value changes, which means Angular lifecycle hooks get triggered, especially ng on changes and ng to check. This setup helps us observe the exact order of lifecycle execution whenever data updates. Now let's run the application and see how the lifecycle hooks execute in real time. When I first load the app, here is the order of execution in the console. As you can see, constructor is called first. This is not part of the Angular lifecycle hooks, but it plays a crucial role in initializing the component and its dependency. And the first thing that is triggered is ng on changes. Since our component receives data from the parents, ng on changes runs to detect any input changes. And then we can see ng on init is executed. This is called once after the component is initialized. It's commonly used for fetching data or setting up subscription, as we mentioned before. And then we can see ng do check is triggered. Angular runs its change detection cycle, checking for any changes in the component step, and so that the ng do check is run. And then we can see ng after content init is executed. Even though we don't have ng content, this is still execute because Angular process projected content, though it is not present there. And then immediately we see ng content checked has been fired. This runs after every change detection cycle to check the projected content. And then we see ng after view init has been executed. At this point, the component view is fully initialized. And then finally, ng after view checked is fired. This ensures the component view and views are updated correctly. Now let me clear the console log and remove the text from the input field. Watch what happens when I delete the text. Even on deleting the text, we can see ng on changes is triggered because the input value has changed. And we can see ng to check and ng after content checked and ng after view check are also executed. Now if I start typing again, we see the same sequence. ng on changes fires and as the input values updates, ng to check triggers to check for the further state changes. ng after content checked and ng after view checked execute once more to verify that the component content and the view remain consistent. Let me clear the console again, and now I'll click the toggle component button. This button hides the lifecycle demo component, and as soon as I click it, watch what happens in the console. As you can see, ng on destroy gets triggered because component is about to be removed from the DOM. And that brings us to the end of our Angular lifecycle hooks. I hope you found this video useful. If you found this video helpful, make sure to like and subscribe our channel for more detailed recipes.